Okay, Bismillah ar-Rahman ar-Rahim. Inshallah, we'll start this section 3.4, the chain rule. It's one of the uh, important sections because most of the functions in real life are function of function. So we need it for sure. Okay, what we have? We have y is a function of u, is a differentiable function of u, and u is a function of x. We have y f of g of x. So it's function of function. We have two ways to do it. We have what's called Lebesgue notation, where you have dy over dx equal dy over du times du over dx. Or you can always remember it like if you are canceling this, canceling dy over dy. Huh? So you can always remember it like this. Or you can write it derivative of f of g of x, which is f prime at g of x, which is the derivative of y with respect to u. So it's prime at g of x. Derivative of u, which is g prime at x. Or in other words, you have f prime at g of x times the derivative of the things inside. So these two are different ways to represent this chain rule. We can apply it now to all previous rules. And if we have function to the power n, not x to the power n, function to the power n, so it's the derivative n, that function to the power n minus 1 times the derivative of the function, which is in this way. The same thing for sine u, it will be cosine u times u prime. Always we have u prime, e to the power u times u prime, and so on. So that's chain rule. Also in this section, they talk about derivative for bases other than e. We know that if y equal e to the power x, y prime is e to the power x. Now if I have a to the power x, what will be y prime? A to the power x times ln a. And if I have a to the power u as a chain rule, what will be y prime? A to the power u. Ln a, don't forget, times u prime. And also we have y, if I have y equal ln x, y prime will be 1 over x. If I have y equal ln u, or ln absolute value of u, I have y prime is 1 over u times u prime. And then if I have y equal log x with the base a, then it will be the same thing, y prime 1 over x, but I have ln a, like what will happen here. Here you have it as a product, here you have it as a quotient. The last one, if y equal log u with the base a, that will be what? Y prime will be 1 over u ln a, don't forget, multiply by u prime. That's all. These are the rules which I need. And this is the chain rule. Okay. Now let us do problems. Here he defined y as a function of u as a function of x. They want dy over dx. Right away, dy over dx will be dy by du times du over dx. Number one. That implies what? Dy over du is what? 2u minus 1 over 2 root u. Du over dx is what? Du over dx is 1. So that would be 2u minus 1 over 2 root u. Don't forget, you want to write the answer in terms of what? Of x. So I have 2x plus 2 minus 1 over 2 root x plus 2. Okay, let me do it in another way. If we write y is u squared minus root of u, I can plug x plus 2 there. So you have x plus 2 squared minus the square root x plus 2. So it will be y prime y prime will be 2 times x plus 2. Derivative of this, which is 1. Who cares? This is, I can think of it as x plus 2 to the power half. So I have minus half x plus 2 to the power minus half. Derivative of this, which is 1. So that will be what? 2x plus 2 minus 1 over 2 root x plus 2, which is the same answer. So this is, I think, I explain it. Where I have in Leibniz notation, here I wrote y as a function of x. I wrote y as a function of x. Then I do the derivative. 2, I'll do it just in Leibniz notation. Y equal 1 over 1 plus u, which is 1 plus u to the power minus 1. So dy by du will be what? Minus 1 plus u to the power minus 2. And they have du over dx is what? 2x plus 1. So dy by dx, which is what they want, will be dy by du times du by dx. Dy by du is minus 1 over 1 plus u square times 2x plus 1. Times 2x plus 1. Or, I don't want u. I want x. I want everything in terms of x. I want everything in terms of x. So I have minus 2x plus 1 over 1 plus, I will plug this u, 1 plus x square plus x minus 1 square, which is minus 2x plus 1 over x square plus x square. Yeah. Now, using the second, خلاص I have function ready, function of x. I need to find dy by dx using the chain rule. 1 dy by dx will be what? This is the power 2 over 3, 1 minus 3x cubed times derivative of this times minus 3 for 3 minus 9x squared, which is what? Cancel 9 with this, I have 3 here. So it will be minus 6x squared, 1 minus 3x cubed. Oh, don't forget, you have 2 over 3. This is minus 1 over 3 to the power minus 1 over 3. In other words, it will be 6x squared over cube root 1 minus 3x cubed. Is it? This is 2 over 3, 1 minus 3x cubed to the power 2 over 3 minus 1, which is minus 1 over 3, times the derivative of this, which is minus 9x squared. Yes. Second one, it's two things. It's product and quotient and the chain rule at the same time. So it will be g prime. It will be the derivative of the first, which is 3x squared minus 1 squared times the second plus a second, and first I mean, times derivative of the second, which is 5 2x plus 3 to the power 4 times derivative of this. I have derivative of the first, which is 3x squared minus 1 squared times derivative of this, which is 2x, times the second, plus the first times derivative of this. How to find the derivative of this? 5 2x plus 3 to the power 4 times derivative of this, which is 2. Okay. Now I can take common factors. I have the numbers is what? 3 times 2, 6. Here I have 5 times 2. So I can take 2 as a common factor. This one, I take the smallest power, 2, between these two. And 2x plus 3, I will take 4, the smallest one. Do the rest. Now what will be that? That will be 3x times 2x plus 3 plus x squared minus 1 times 5. That will give us what? 2x squared minus 1 squared, 2x plus 3 to the power 4 times what? 6x squared plus 9x plus 5x squared minus 5. In other words, this is again the same. I have 11x squared, yeah, plus 9x minus 5. Yes. Number 3 is what? H of x, I can rewrite it as what? Rewrite it as a power. It's 1 minus x plus x cubed to the power half. Plus. So it will be h prime of x. It will be half this to the power minus half times derivative of this. هو minus 1 plus 3x squared. I can rewrite it as what? I have in the numerator minus 1 plus 3x squared. The denominator I have 2 square root of this. Wait a minute. Sorry. This is not to the power half, this is the power minus half. It's in the denominator. So h prime of x will be minus half 1 minus x plus x cubed to the power minus 3 over 2. Yeah, and this is minus 1 plus 3x squared, which is the derivative of this. That will be minus, I have minus time this, so it will be 1 minus 3x squared over 2 square root s cubed. Yeah, this is minus half. This is in the denominator. It's 1 over this. That's square root of it. Yeah, so it's minus half this to the power minus 3 over 2 times derivative of this. Minus times minus, make it 1 minus 3x squared over. Okay. This one, or f prime, or first let me write f. This is, I can write it here. That will be what? 1 over x plus 1 to the power half. خلاص. So it will be f prime half 1 over x plus 1 to the power minus half times derivative of this, which is minus 1 over x squared. So that will be what? Minus 1 over 2. This is similar to this. Square root 1 plus x over x. This one is the same as this one. Huh? And it was in the denominator, the door minus half, and they have x squared here. Okay. So that will be what? Minus 1 over 2 root 1 plus x times x to the power what? 3 over 2. Yeah. Yeah. This is x squared. This is x to the power half. That will be x to the power 3 over 2. In other words, can be written minus 1 over 2 root 1 plus x x cubed. That will be minus 1 over x to the power 4 plus x cubed. Minus 1 over x to the power 4, square root of x to the power 4 plus x cubed. Yeah. Okay. Half, this is 1 plus x plus 1 to the power minus half, which is the same as minus 1 over x squared. It's minus 1 over 2 root 1 plus x over x, which is the same. This is 1 plus x over x under square root under in the denominator times x squared in the denominator. Yeah. So x to the power 3 over 2. Take it inside, x cubed, 5. Find the derivative at x equals 0 for this function. خلاص. Y prime will be minus 3, 1 minus x squared over 1 plus x squared to the power minus 4 times derivative of this quotient rule, which is what? Derivative of the numerator في denominator minus derivative of the denominator numerator over 1 plus x squared all square. Is there a need to simplify it? No. Since I want to find it at 0, especially at 0, 0 cancel many things. Huh? Actually, the answer will be 0. This is minus 3, 1 minus 0, which is 1 to the power minus 4, times what? I have here 0 minus 0 over 1. So the answer is 0. Find the slope of the line tangent, like these previous finds. What I need to do, I need to find the derivative. M tangent will be f prime at 1. But to find the derivative, I need the implicit differentiation. So f prime, f of prime of x will be 4x plus cube root of x to the power 3 times derivative of this, which is 1 plus, this is x to the power 1 over 3. Huh? I can write it. X to the power 1 over 3. So it's 1 plus 1 over 3, x to the power minus 2 over 3. Make a bracket to be sure. This is the derivative. So it's 4, this to the power 3, or u to the power 3 times derivative of u. 1 plus 1 over 3, x to the power minus 1. A prime at 1, it will be 4, 1 plus 1 cubed times 1 plus 1 over 3. So that will be 4 times 8 times 4 over 3, which is 32 times 4, 128 over 3. Find f prime at 2 for this function. Let me do this one here. Don't forget, e to the power minus 3. What's the derivative of e to the power minus 3? This is just a value. This is just a constant. So the derivative will be 0. So actually, you need to do this only. Huh? Rewrite the function, make it as product, maybe it will be easier. That will be x, 1 plus x cubed to the power minus half plus e is minus 3. This is my f. So now let me do f prime. F prime will be what? Product. I have product rule here. So it will be 1 plus x cubed to the power minus half. This is going to constant. خلاص out. This derivative of x, which is 1 plus x times what? Minus half 1 plus x cubed to the power minus 3 over 2 في derivative of this, which is 3x squared. Now I will take 1 plus x cubed to the power minus 3 over 2 common factor. I have here 1 plus x cubed plus or minus, it will be. It will be minus what? I have 3x squared times minus half times x. Okay, so it will be minus 3 over 2x cubed. So that will be what? 1 plus x cubed to the power minus 3 over 2 times minus 3 over 2 plus x cubed minus half x cubed plus 1. Okay. Number 2, it's ready. It's just product. So derivative of the first, or I can rewrite it as x plus 1, make it powers. It'll be easier. So derivative of the first is 1, خلاص gone. So you have the second, the same idea actually. Plus x plus 1 times what? Half x cubed plus x minus 1 to the power minus half. Derivative of this, 3x squared plus 1. So that will be what? I can take this to the power minus half, the common factor. The remaining is cube plus x minus 1 plus. Here I have what? Half x plus 1 times 3x squared plus 1. Do the calculations. That will give me what? X cubed plus x minus 1 to the power minus half. Here I have what? X cubed plus x minus 1. Here I have x times 3x squared, which is plus 3 over 2x cubed. And I have what? 3x squared also plus 3 over 2x squared plus x plus half x plus half. So that will be what? X cubed plus x minus 1 to the power minus half. Now do the calculation. I have x cubed, 3 over 2x cubed. That is 5 over 2x cubed. I have plus 3 over 2x squared. Okay. And they have what? Half x plus 3 over 2x minus half. Actually, I can take half out. Yeah, it's okay. And you can write it as half. Actually, maybe if I make the half out from the beginning, it will be easier. If I use half, okay, it's okay. Yeah, I think we need to do it this way. Okay, half x cubed plus x minus 1 to the power minus half times 5x cubed plus 3x squared plus 3x minus 1. I think this is the best. Okay, 3. Now, example 9. Okay. Example 9. Okay. Now, he did not give me a function, but he gave me some information about these functions. So let me do this. So capital F prime, it will be F prime at g of x times g prime at x. So that implies capital F prime at 3 is F prime at g at 3 times g prime at 3. Let us do the calculation. F prime g at 3 is 6. F prime at 6 times g prime at 3. What is f prime at 6? It's here. It's 7. What is g prime at 3? It's 4. The answer is 28. Find the derivative of the following functions. Now we have these trig functions. Do the same thing. Number 1, chain rule. What's the derivative of tan? Is secant square 4x times derivative of this, which is 4. So it will be 4 secant square 4x. 2, y prime will be what? Secant square at sine x, derivative of this, cosine x. So that will be cosine x times secant square at sine x. Huh? I cannot cancel cosine with secant because it's a different angle. Huh? This is cosine x, this is secant square sine at sine x. Okay. This is number 3. I can write it 1 plus tan x to the power 1 over 3. So number 3, y prime is what? 1 over 3, 1 plus tan x to the power minus 2 over 3 times derivative of this, which is secant square x. So it will be secant square x over 3 cube root 1 plus tan x all square. Find y prime for all of these functions using these log things. Okay. I think they are quick. Number 1, let me do it here. Y prime will be what? If you remember the formulas, we say I have this. Log x with the base, log u with the base a. So it will be 1 over ln a times u times u. Okay, we'll do the same. So it will be 1 over ln a, which is ln 3, times u, x squared minus 1, times derivative of u. So that will be what? 2x over ln 3 times x squared minus 1. Number 2, y prime will be what? Same idea. I have ln 2 times u, which is sine x plus cosine x, derivative of this, which is cosine x minus sine x. That's it. 3. 3, I can rewrite it as what? Log the base 3 of x squared plus 2x plus 2 all to the power half. Okay, so it will be half log with the base 3 of all of this, but to the power minus half, times derivative of this now, which is 1 over ln 3 for u times derivative of u, which is 2x plus 2. This one I can simplify. Note I have, this is 2x plus 1. So this 2 cancel with this 2. So I have 2x plus 2 over what? Ln 3 x squared plus 2x plus 2. And I will put this. Square root log with the base 3 x squared plus 2x plus 2. Okay. Or ln 1 plus tan x at all y prime is 1 over 1 plus tan x times derivative of tan x, which is secant square x. That's it. 5. I have product of two functions. Once derivative of the first, which is 1 times the second, plus x times. I have 1 plus ax. Here I have ax. Derivative of this, which is ax. So that will be what? Ln 1 plus ax plus x ax over 1 plus ax. Yeah. Number 6, I have quotient. So y prime will be what? Derivative of the first, derivative of the numerator, 1 over x times the denominator minus the denominator, 1 times ln x over x squared. And that is what? 1 minus ln x over x squared. That's number 6. Number 7, I can rewrite it as what? As ln x squared all cubed. And that will be what? 2 ln x all cubed. And that will be what? 8 ln x all cubed. Okay, now I'll do the derivative. Y prime will be 8 times 3 ln x all square, derivative of this 1 over x. So that will be what? 24 ln x square over x. Okay. Number 8, y prime will be what? 1 over x. We did it before. Number 9, y prime will be what? 1 over x squared minus 5 times the derivative of this, which is 2x. Remember, we did it here, huh? This one. What's the derivative of ln absolute value of u? It's u prime over u, huh? Like derivative of ln u, huh? Is the same, huh? These two are the same. Okay. Yeah. Number 10, ln of ln x, huh? It's, just to be sure, it's ln of ln x. So y prime, I have 1 over u times derivative of u times derivative of this, which is 1 over x. So it will be 1 over x ln x. 1 over x ln x, yeah. Find y prime. Now I have these things, huh? I have these formulas. A to the power u. I have these formulas. A to the power u. So I have ln a times a to the power u times the derivative. Number 1, y prime, the same, times ln a times derivative of this. اللي هو 6x squared plus 5. Second one, y prime will be what? 3 to the power sine x times ln 3, this is my a, derivative of this, no cosine x. This one, just to be sure about you understand the higher order derivative. What's the meaning of the third derivative? Means you need to find the first derivative, second derivative, third derivative. Do it step by step. F prime is 4x cubed minus 6x. F double prime, which is the derivative of the first derivative, 12x squared minus 6. Third will be what? 24x. That's it. But they want triple at 2, which is 24 at 2, which is 48. Find the first 4 derivative and the nth derivative for each of the following. Okay. Yeah, the first one is very clear. What will be y prime? Ax. Second, ax. Third, ax. That means what will be the nth derivative? It will be, yeah, at x is ax. Okay. Now we'll come to the second one. Y equal 1 over x, which is x to the power minus 1. Now we need to look for a pattern. Okay. Y prime minus x is minus 2. Y double prime will be 2. X is minus 3. Y triple, it will be 2 times minus 3. Don't do the product to see the pattern. Y fourth, it will be 2 minus 3 minus 4. X to the power minus 5. This is y fourth. Y fifth, it will be 2 minus 3 minus 4 minus 5. X to the power minus 6. Okay, خلاص. Let me try to think about the end derivative now. It will be x to the power what? First, it's minus 2. Second, minus 3. Third, minus 4. Fourth, minus 5. So it will be minus n plus 1. It's a minus, but the value is n plus 1. Huh? I have the first derivative 2, second derivative 3, third, and all those times minus 1. Okay. Now we'll come to the value. I have this one, you can think of it as 2 factorial x minus 3. This one minus 3 factorial x to the power minus 4. This one 4 factorial x to the power minus 5. This one minus 5 factorial x to the power minus 6. Yeah. So if you notice the number, forget the sign. 2, 3, 4 factorial, 5 factorial, the same thing. 4, 4 factorial, 3, 3 factorial, and so on. So it will be n factorial. Now we'll come to the sign. The first, it's minus. By the way, this one also you can write it minus 1 factorial x to the power minus 2. Okay. So with the first, it's minus. With the second, it's positive. Third, minus. So with the even, positive, and with the odd, negative. So I can rewrite it as minus 1 to the power n. Since the odd will make it negative, but the even will make it positive 1. So that will be the answer. Find y double prime. This is we're not looking for a button, just we need to do the calculation. So f prime, this I can write it what? 2, 3x minus 1 to the power minus 1. So f prime will be minus 2, 3x minus 1 to the power minus 2. Don't forget, times 3. So it will be minus 6, 3x minus 1 to the power minus 2. This is first derivative. Second derivative, which I'm looking for, y double prime. Yeah. Second derivative will be what? 12, 3x minus 1 to the power minus 3 times 3. So that will be 36 over 3x minus 1 cubed. Second problem. F prime would be what? Product here. Derivative of the first is 2x ax plus the first times derivative of the second, and that will be what? X squared plus 2x ax. What will be f double prime? Have derivative of this 2x plus 2 times the second plus the first times derivative of the second. And that will be what? Now, that will be x squared plus 4x plus 2 e to the power x. Okay. Third one, f prime will be what? Same thing, huh? Sine x plus x cosine x. F double prime will be what? Cosine x plus, here I have product rule again. That is, will be cosine x minus x sine x. So the answer is 2 cosine x minus x sine x. Okay, now we need to find the end derivative for these functions. Okay, let me do the first. F prime is 1 over x minus 1, which is x minus 1 to the power minus. Second derivative, let's see the pattern, huh? It's minus x minus 1 to the power minus 2. Derivative of this, which is 1. Who cares? Third is 2 x minus 1 to the power minus 3. Fourth is 2 for minus 3 for x minus 1 to the power minus 4. Can you decide about the end derivative? Yeah, we can think about the end derivative, I think, easily. The end derivative will be what? I'll have x minus 1 to the power minus n, since fourth minus 4, third minus 3, second minus 2, first minus 1. Okay. And they have the same thing. Here we have what? Minus 3 factorial, x minus 1 to the power minus 4. Here we have 2 factorial, x minus the power minus 3. They have what? N minus 1 factorial. Whereas the third, they have factorial, fourth, they have 3 factorial, and so on. Then it comes to the sign. The sign is different here. With the odd, it's negative. The even, it's with the odd, with 1 and 3, it's positive. With the even, it's negative. So I will x minus 1 to the power, we said what, minus n. And this one I have n minus 1, n minus 1 factorial. And this will be minus 1 n plus 1. So for the odd, it will be positive, and for the even, it will be a negative. Okay, number 2. E to the power 2x. We did e to the power x here, which is nothing. But now I need e to the power 2x. Okay, let me do, I think it's easier. Also, it's not that difficult. E to x. Second, 2 times 2 e to x. In other words, 2 square e to x. Very clear, I think. The end derivative will be, if we continue, 2 to the power n e to x. Okay, third one. Y equal x to the power half. So y prime is half x minus half. Okay, y double prime half times minus half times x to the power minus 3 over 2. Y third derivative, it will be half minus half minus 3 over 2, x to the power minus 5 over 2. Y fourth will be half minus half minus 3 over 2 minus 5 over 2, x to the power minus 7 over 2. Yeah, let me try now to think about the end derivative. Okay. Here I have x to the power minus something. This minus half, look at this, minus half, I can write it as what? Yeah. You can write it 1 minus half. And this one, I can write it 2 minus half. No. Half minus 1, I mean, the other way. It's a negative. half minus 1. This one without minus. Minus 3 over 2 is 2 minus half. Minus 5 over 2 is 3 minus half. Same problem. Half minus 2. It's either you take the minus out or you keep it inside. Huh? Half minus 3. So this one, I can write it half minus 3. Yeah, x to the power half minus n. Okay, this is the power. Now I have a numerator and denominator. The denominator is, here I have 2, here I have 2 squared, here I have 2 cubed, here I have 2 to the power 4. This is the fourth derivative, this is the third derivative, so I have 2 to the power n in the denominator. Okay. Now it comes to the numerator. In the first one, let me deal with the sign. Positive, second negative, third negative, third positive, minus positive, so it will be minus 1 to the power n plus 1. With the even, it's negative. With the odd, it's positive. And now this number, yeah, there is no easy way to do it, but it will be written like this: 1 times 3 times 5 times until what? 2n minus 3. Yeah. If you notice, yeah, maybe I need to do the fifth one to see it better. That will be x to the power minus 9 over 2. This one will be 2 to the power 5, because I need 2 there. Here I have 1. Forget about the minus. It will be minus positive. So it will be 1 times 1 times 3 times 5 times 7. So it will be 1 times 3 times 5 times 7 and so on. But I will stop where? With the fifth, I stop at the 7. So fifth, 2 times 10 minus 3 is 7. Now it comes to the fourth, I need 1 times 3 times 5. So it will be 8 minus 3, which is 5. So this is the way to do it. Okay. Let me, yeah, do 2 more, then I will stop. Find the 50th derivative of this. Okay. Remember when we dealt with cosine and sine, we said there is every 4 times they will repeat itself. Okay, so let us see what will happen if I have cosine of a value. First derivative, it will be minus sine 2x times 2. Second, it will be minus 2 cosine 2x times 2. Third, this will be minus 4. That will be minus 4. So it will be minus 4. No, it will be plus 4. 4 sine 2x times 2. Fourth will be 8 cosine 2x. Don't make it 8. I think better to keep it like this. Yeah, this is 2 square sine 2x. This one, yeah, this will be not 2 square. Wait a minute. This is, yeah, let me write it here. Minus 2 square cosine 2x. This one will be what? Minus 2 square plus, not minus, sine 2x times 2, which is 2 cubed sine 2x. This one, it will be 2 to the power 4 cosine x. I think very clear. So what will be the end derivative? The end derivative, or let me say the 50th derivative. 50th derivative. I know every 4. Now the number is 2 to the power something, 2 to the power n. The number 2 to the power n, 2 to the power 3. But the value, it depends on the, I have cosine 2x. So the number is doing this, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, and so on. Here I have minus sine 2x. Here I have minus cosine 2x, just to see it. This here I have sine 2x. Here I have cosine 2x. So what will happen to the 50th? This is the first. What is the 50th? 1 check over 4. That give me what? 1, 4, 10, 2, 8, 2. So the 50th derivative, that implies if we continue, the 50th derivative is the same as the second derivative, only in this. Okay, in this part. Times a number. The number will be 2 to the power 50. Second derivative is what? Is this one. That is minus cosine 2x. So it's minus 2 to the power 50 cosine 2x. I hope it's clear. Now they want the end derivative for this. Just do 1 or 2 steps, you will notice it. This will be what? Es minus x es minus x, which is 1 minus x es minus x. Second derivative of this, which is minus es minus x plus 1 minus x es minus x was derivative of this minus 1, so that will be minus. So it will be x minus 2 es minus x. Third, it will be what? Es minus x plus x minus 2 es minus x. Times minus because of this. So it will be minus. So that will make it 3 minus x to the power es minus x. So it's very clear. It's times es minus x always. And this is will be 1 minus x minus 2, 3 minus x. So for the even, it's x minus the number. For the odd, it's the number minus x. 1,000 derivative. What will be the 1,000 derivative? Even. So we'll go with this. So it will be x minus 1,000 es minus x. Yeah. Let me finish by this. Just you need to plug this. So you need to find y prime r e to the power rx, y double prime r square e to the power rx. Plug these there. So I have y double prime minus 4y prime minus 5y is equal to what? R square erx minus 4 r erx minus 5 erx. That should be equal to 0. So take e to the power rx common factor. I have r square minus 4r minus 5 equal to 0. This is impossible to be 0. And the only possibility is that r square minus 4r minus 5 equal to 0. which means r minus 5, r plus 1 equal to 0. So we have r equal 5 or r equal minus 1. Yeah, the next time we'll talk about, now we'll go to have function of function. Huh? We have function of function of function. Then I will do more problems in that. Let me stop here. Yeah. Thank you.